Memorial Day weekend. Carol's daughter had driven from Tucson with the grandchildren. First real family visit in almost a year. The backyard smelled like charcoal and sunscreen. Grandkids chasing each other through the yard. American flag hanging off the back porch the way it does every year. And Carol, 73 years old, retired biology teacher from Phoenix, Arizona, spent the entire cookout sitting in a lawn chair. Her feet hurt. Her energy was gone. By the time the sun went down, she was dizzy. Her daughter crouched down in front of her and looked her in the eye. And she said, Mom, I need you to be here for my kids, not just today. I need you to actually be here. 3 days later, Carol sat in her endocrinologist's office. A 1C9. Her doctor looked across the desk and said the words she had been dreading for 2 years. Carol, if this number climbs any higher, we are starting insulin. 11 years managing type 2 diabetes. 11 years of medication adjustments, diet changes, walking programs she couldn't sustain on 2 knees that had both been operated on. The number kept climbing. She told me later, and I want you to hear these words exactly. I taught human physiology to teenagers for 40 years. And I sat in that office not understanding what was happening inside my own body. 90 days after that appointment, Carol's A1C was 6. Her endocrinologist asked her 3 times what she had changed. She told him. He wrote it down. And then he said, and she told me this word for word, I should have known about this years ago. A fruit, not a supplement. Not a prescription. A fruit available right now at Costco, Trader Joe's, and most large grocery stores across the United States for less than $3. And the reason Carol's endocrinologist had never mentioned it is the same reason yours probably hasn't either. I've spent over 20 years working with patients managing blood sugar and insulin resistance. And what I'm about to show you today, the 5-mechanism chain that drove Carol's results, I have never laid out in a single video before. 5 mechanisms, each one deeper than the last. By the time we reach number 1, the title question answers itself. Let's begin. Before we go any further, I need to ask you something. And I mean this. Is there someone in your life right now, a spouse, a parent, a sister, a close friend, who is sitting somewhere today with an A1C above 8, who has been fighting this for years and feeling like they are losing ground? Who has been told insulin is the next step? Share this video with them right now before you watch another second. Not because I want the views, because the information I'm about to give you, the mechanism behind what happened to Carol, should have reached your people through their doctor's office. It didn't. It won't. That is not an accident. That is a pattern. And it has a name, but I'll save that for later. Text it, share it, send it to someone who needs it, and then come back. Because what happens next in this video is the most important thing I've put on this channel in a long time. The fruit is pomegranate, and I already know what just happened in your mind. Pomegranate is sweet. How does a sweet fruit lower blood sugar? That is the right question. And the answer is exactly why your doctor has never recommended it. Most physicians are trained to evaluate food through 2 filters, glycemic index and total sugar content. Pomegranate has natural sugar. It scores as a moderate glycemic food on paper. It gets filtered out. What that filter misses entirely is the biological matrix surrounding those sugars. Pomegranate contains a family of polyphenols called punicalagens. These are compounds so structurally complex and processed through such a specific biological pathway that they sit in the nutrition literature rather than the pharmacology literature. And the pharmacology literature is where blood sugar research gets funded. Carol was a biology teacher for 40 years. She understood every mechanism I'm about to describe, and she looked at me and said, I taught the endocrine system to teenagers. Not one word of this was in my curriculum. 5 reasons, weakest first. Number 5. The polyphenol glucose break. Here's how most people think pomegranate might help blood sugar if they think about it at all. Antioxidants reduce inflammation. Inflammation drives insulin resistance. Less inflammation, better insulin response. Correct, and not the point I want to make here. Pomegranate's punicalagens, alongside ellagic acid and anthocyanins, form what researchers describe as a polyphenol matrix around the fruit's natural glucose content. When this matrix reaches your small intestine, it physically slows how fast glucose passes through the intestinal wall into your blood. Not stops. Slows. The blood sugar curve from eating pomegranate seeds flattens dramatically compared to a food with equivalent sugar and no polyphenol matrix. The spike that would happen from isolated sugar is moderated from inside the food itself. A study published in Nutrition Research found that pomegranate consumption significantly reduced postprandial blood glucose response compared to a glucose-matched control. The effect attributed directly to the polyphenol content interacting with intestinal glucose transporters. The fruit carries its own biological break inside itself. And we've been filtering it out based on a sugar number that tells us nothing about what the surrounding matrix does. Kitchen moment. Eat the seeds, the arils, the deep red jewel-like seeds directly. Not juice, not a blended smoothie, the seeds themselves. The moment you juice pomegranate, you strip the fiber matrix. The biological break comes off. The blood sugar benefit from pomegranate juice is a fraction of what whole seeds deliver. And some commercial formulations actually raise postprandial glucose. The wonderful brand ready-to-eat arils at Costco, about $5 for a 12-ounce package, or a whole pomegranate at Trader Joe's for around $2. Seeds, not juice. This distinction matters throughout everything I'm about to show you. Number 5 is the surface layer. Number 4. Number 4 is something I've never said in a video on this channel before. Real quick before number 4, I want to hear from you. Drop a comment. How many years have you been managing blood sugar? 1 year? Gee. 25? I read every single one, and I genuinely want to know who's in this room with me today. Okay, number 4. Most of the blood sugar content I cover focuses on protecting beta cells, the cells in your pancreas responsible for producing insulin, protecting what you have. I have never discussed what happens when you give those cells the right compounds at the right concentration. In long-term type 2 diabetes, after 10-15 years of elevated blood sugar, beta cell mass decreases. The cells die faster than they regenerate. This is why insulin eventually becomes necessary for many people who've been managing this for years. Not because insulin sensitivity collapsed, because the production capacity physically diminished. A study published in Phytotherapy Research found that pomegranate extract activated a protein called NRF2 in pancreatic tissue. NRF2 is a master regulator of cellular repair. It reduces the oxidative destruction driving beta cell apoptosis and stimulates markers suggesting increased viable insulin-producing cells over time. And I want to be precise here because this deserves precision. The human clinical research on beta cell regeneration is still developing. What the studies consistently confirm is a significant reduction in beta cell destruction and markers suggesting increased viable insulin-producing cells over time. The regeneration signal is real. The clinical magnitude in long-term human diabetics is still being studied. But for Carol, someone whose pancreas had been under attack for 11 years, this mechanism may be exactly why her response was so dramatic. Not just improved sensitivity, improved production capacity. And to those of you on metformin, I see you. Many of you have been on it for over a decade. I am not standing here telling you to stop. That is between you and your doctor. What I'm telling you is that pomegranate appears to address the one part of your biology that metformin was never designed to touch. The cells doing the producing. I wrote something called the midnight insulin trap. It gets into the overnight beta cell stress cycle specifically. What happens to your insulin production between midnight and 4 while you sleep? The link is in the description below. Number 4 is the cells that produce. Number 3 is the organ that floods your blood while you sleep. Number 3. If your fasting blood sugar is elevated every single morning and you cannot explain it by anything you ate the night before, this mechanism is responsible. Not your dinner, your liver. In insulin resistance, your liver's overnight glucose release becomes deregulated. Instead of a controlled slow drip of glucose to support brain function during sleep, it floods your bloodstream. You wake up after 8 hours of fasting with a number that makes no sense. You did everything right and the meter still reads high. This is hepatic glucose overproduction. And it is responsible for elevated fasting glucose in the majority of type 2 diabetics regardless of diet. Punicalagins from pomegranate activate AMPK in hepatic tissue. When AMPK fires in your liver, it suppresses gluconeogenesis, the process by which your liver manufactures new glucose from stored compounds overnight. A study published in the Journal of Nutritional Biochemistry found that pomegranate polyphenols significantly reduced hepatic glucose output through AMPK activation, with the effect sustained across multiple hours, not limited to the active digestion window. Multiple hours, not while you're digesting pomegranate. Through the overnight window your liver operates in while you sleep. Carol's fasting numbers were the ones that confused her most. Careful dinners, consistent medication, and every morning the number was still there. At week 4 of her protocol, she told me her morning fasting number had dropped an average of 22 points before she changed anything else. Kitchen moment. Eat pomegranate seeds 30 minutes before dinner, not after, not as dessert, before. You want punicalagins in your system as your liver begins ramping toward its overnight activity window. The timing is the intervention. Same food, wrong timing, meaningfully lower results. Number 3 is the liver. Number two is the most controversial mechanism in this video. And when you understand it, the title question answers itself completely. Why don't doctors prescribe this? This is why. Number two, you may have heard of a medication called Ozempic semaglutide. It's been called a revolution in diabetes and weight loss treatment. Its manufacturer reported over $20 billion in revenue in a single year. The reason it works, the core biological mechanism, is that it mimics a hormone your gut produces naturally. That hormone is called GLP-1, glucagon-like peptide 1. When GLP-1 is active in your body, your pancreas releases insulin in direct proportion to actual circulating glucose, a precise calibrated response instead of a blunt wave. Your liver receives a signal to slow glucose output. Intestinal glucose absorption is moderated. Your body has a GLP-1 system. It existed long before semaglutide was synthesized. Ozempic works by flooding that system with a synthetic hormone analog that resists degradation. It forces GLP-1 activity that your body was supposed to be producing on its own. Here's what nobody explains on the evening news. Your gut produces GLP-1 in response to signals from specific bacteria in your microbiome. When those bacteria receive a particular substrate, specifically short-chain fatty acids produced from fermenting certain polyphenols, intestinal L cells receive the trigger to produce GLP-1 naturally. Pomegranate's punicalagins are fermented by gut bacteria into short-chain fatty acids. Those short-chain fatty acids signal your intestinal L cells. Your L cells produce GLP-1 naturally, inside your own body, from food you grew in a backyard or bought at a grocery store. A medication that mimics this process costs over $1,000 a month for most Americans without insurance. The clinical trials proving it works were funded entirely by the company selling it. The research on pomegranate's gut microbiome GLP-1 pathway, published in peer-reviewed journals, no pharmaceutical funding required. Your doctor's office has a pharmaceutical representative visiting every other Tuesday. They do not have a pomegranate representative. A study published in Nutrients 2022 found that pomegranate polyphenol consumption significantly altered gut microbiome composition, increasing populations of bacteria associated with short-chain fatty acid production and improving markers of insulin sensitivity and GLP-1 signaling. The magnitude is not equivalent to a pharmaceutical dose of semaglutide. I want to be precise about that. This is not Ozempic in a fruit. What it is your body's own GLP-1 system being fed the raw material it was always designed to receive. For a patient whose natural production has been underperforming for a decade, that is not a small thing. Carol's endocrinologist reviewed her labs at the 90-day mark. He noted that her GLP-1 markers had improved. He looked at her and said, and she told me this, "I don't see GLP-1 numbers move without medication." He didn't have an explanation. Now you do. The midnight insulin trap covers the overnight GLP-1 window specifically. What happens to this hormone during deep sleep and how it interacts with your morning fasting number. If your mornings are the problem, that is the missing layer. Link is in the description. Number 2 is GLP-1. The system your body built long before a pharmaceutical company arrived to sell it back to you. Number one is the mechanism that Carol's endocrinologist had never encountered, that a 40-year biology teacher had never heard of, and that I would genuinely bet is not in a single other video on this platform. Number 1, deep in your large intestine, past where most digestion occurs, live bacteria that mainstream medicine has only recently begun to understand. Their names read like academic footnotes. Gordoniobacter pomeliae, Helicobacter isocincovia. You have never heard these names? Almost nobody has. These bacteria perform one specific task. When punicalagins from pomegranate reach the large intestine, these bacteria convert them into a compound called urolithin A. Urolithin A does not exist in the pomegranate itself. It is not something your body manufactures independently. It only exists when the right food, carrying the right precursor, meets the right bacteria in your gut, and the conversion happens. Here's what urolithin A does. Urolithin A activates AMPK in muscle cells, the same protein that exercise activates, but it does this through a completely different entry point. Exercise triggers AMPK by depleting muscle energy stores. Your cells run low on fuel. AMPK fires, glucose gets pulled from the bloodstream. Urolithin A activates AMPK through mitophagy signaling. Mitophagy is a cellular cleanup process. It identifies damaged mitochondria, the energy-producing structures inside your muscle cells, and removes them, clears them out, replaces them with functional ones. In plain terms, urolithin A instructs your muscle cells to discard the damaged energy machinery that was making them inefficient at absorbing glucose and replace it with machinery that works. Actually, let me say that one more time because this is the part that stopped me Urolithin A doesn't just force a door open, it repairs the door mechanism itself. Research published in Nature Metabolism from the laboratory of Johann Auwerks at the Swiss Federal Institute of Technology in Lausanne found that urolithin A improved muscle cell insulin sensitivity, AMPK activation, and mitochondrial function in aging adults. The researchers specifically noted the compound's unique ability to activate mitophagy, a process that declines significantly with age, and its downstream effects on glucose metabolism. That last point, the decline with age, this is critical. Mitophagy, the cellular cleanup process, urolithin A, triggers drops dramatically after 60. Your muscle cells accumulate damaged mitochondria faster than they can clear them. Insulin resistance in people over 70 is partly, and nobody says this clearly enough, a mitochondrial problem. Damaged mitochondria that cannot respond properly to insulin signals, old machinery. Urolithin A initiates the replacement, and if you are managing type 1, I see you. The AMPK and mitophagy pathway I just described operates independently of insulin production. What urolithin A activates in muscle tissue is relevant regardless of type. Now here's the part that should make you quietly furious. Urolithin A is currently being developed as a pharmaceutical compound. Clinical trials are running, patent applications are filed. Within the next 5 to 10 years, there will very likely be a prescription product delivering concentrated urolithin A at controlled dosages. The precursor, punicalagins, is sitting in a fruit that has existed for thousands of years, available at most grocery stores across the United States for under $3. The mechanism by which your gut bacteria converts it into urolithin A has been in the peer-reviewed literature since at least 2012. They are not going to prescribe pomegranate. Pomegranate is not patentable. Kitchen moment. And this is the part most videos on this fruit completely skip. Not everyone produces urolithin A from pomegranate. This depends on your gut microbiome composition. Roughly 30 to 40% of adults do not carry sufficient populations of the converting bacteria at baseline. How do you change that? Consistent pomegranate consumption over 4 to 6 weeks rebuilds the bacterial populations that perform the conversion. Your microbiome is not static. It responds to what you consistently feed it. But there is one additional food that accelerates this dramatically: walnuts. Walnuts contain L-glutathione, the same polyphenol precursor class as punicalagins. Together, pomegranate and walnuts create compounding environmental pressure for urolithin-producing bacteria to grow in your gut. One small handful of walnuts alongside your pomegranate seeds, same sitting, every day, 4 weeks. Carol's protocol included both from week 1. She didn't know why at the time. Now you know exactly why. All right, science is done. Let me give you the kitchen version. 3 preparations, each designed for a different situation. Pick the one that fits your life and start tonight. Preparation 1, the pre-dinner protocol. Half a cup of pomegranate arils 30 minutes before your largest meal. The wonderful brand ready-to-eat seeds at Costco, about $5 for a 12-ounce container, or 1 whole pomegranate at Trader Joe's, seeded yourself. No juice, no sweetener, seeds only. If the tartness is too strong, mix with 1 tablespoon of plain full-fat Greek yogurt, no added sugar. The protein buffer moderates the tartness without disrupting the polyphenol activity. Preparation 2, the morning activation bowl. A 1/4 cup of pomegranate orioles, 6 to 8 walnut halves, and half a cup of plain Greek yogurt. Eaten before or with breakfast. The yogurt adds probiotic bacterial strains that support the broader gut microbiome environment for urolithin A conversion. The walnuts provide the L-glutathione substrate. This combination is as close to a full urolithin A production protocol as food alone can achieve. For those avoiding dairy, unsweetened coconut yogurt, same structure, same benefit. Preparation 3, the year-round option.